So today we are going to discuss homogeneous linear differential equation, okay, called Euler-Cauchy equation. So write down Euler-Cauchy equations, or you can write homogeneous linear differential equations. Homogeneous linear differential equations. So what type of equations are called as Euler-Cauchy equations or homogeneous linear differential equations? Okay. So an equation of the form, an equation of the form, an equation of the form, say a square x square, okay. So we write d square y by dx square plus ax dy by dx plus y is equal to q, or in general x to the power of n into d power n y by dx to the power of n plus a1 x to the power of n minus 1 into d power n minus 1 y upon dx to the power of n minus 1 plus a2 into x to the power of n minus 2 into d power n minus 2 y upon dx to the power of n minus 2 plus etc. up to a n minus 1 into x into dy by dx plus a n into y equal to q. Let us call this equation 1. Okay. An equation of this form is said to be an Euler-Cauchy equation, is called an Euler-Cauchy equation where ai's, that is a1 a2 up to an, are all constants and q is a function of x, and q is a function of x. Okay, so how to solve this kind of questions? Okay, so in order to solve this kind of problems, what we do is we have to reduce this equation to the linear differential equation with constant coefficients with some substitutions. So what is that kind of substitution which can reduce this Euler-Cauchy equation to the linear differential equation with constant coefficient? Okay, so let us see that. So such equations can be reduced to linear differential equations with constant coefficients okay, by the substitution x is equal to e power z, or we can say z is equal to log x. So what we do here is we are going to change the independent variable x to some other variable z. Okay, so thereby we take dy by dx. Okay, let us see how to write dy by dx in terms of z. So here we write it as dy by dz into dz by dx. So what we write? So we write it as dy by dz into dz by dx. So from this we are writing the value of dz by dx. What is the value of dz by dx? We get 1 by x. So this 1 by x we need to write in place of dz by dx. Okay. So now by cross multiplication we get x into dy by dx is equal to dy by dz, and this can be taken as dy, where this capital Z d is given by d by dz. Fine, this is the substitution for dy by dx into x. Okay, so that can be written as dy, where d is d by dz. So now the question is what to write for d square y by dx square, right? So let us see that also. Also, d square y by dx square can be taken as d by dx of dy by dx. So now what we have for dy by dx, that we substitute here, that is 1 by x into, okay, 1 by x into, what is that, dy by dz. So this term we need to differentiate with respect to x now. Okay, so we can apply product rule. So that is giving us minus 1 by x square into dy by dz, first function into derivative of second, and derivative of second into first function into derivative of second plus second function into derivative of first. So plus we get 1 by x into d square y by dz square into dz by dx. Okay, so again we substitute for dz by dx. What is that? 1 by x. Okay, so we write therefore minus 1 by x square into dy by dz minus 1 by x into 1 by x, 1 by x square into d square y by dz square. Okay, so from this you take 1 by x square as common and cross multiply. So by cross multiplication we are going to get, and yeah, so by cross multiplication we are going to get, this is positive, sorry, okay. So by cross multiplication of x square we get x square into d square y by dx square is equal to, what is that, d square y by dz square can be taken as d square y minus dy, written for dy by dz. So from this you can take d outside and write d into d minus 1 of y. Okay, similarly we can write for x cube into d cube y by dx cube as d into d minus 1 into d minus 2 of y. Okay, so by substituting all this data in the given equation 1, we get a linear differential equation with constant coefficients, which can be solved by the known methods already, which are discussed. Okay, yeah, so we'll write it. On substituting the values of x into dy by dx, x square into d square y by dx square, comma x cube into d cube y by dx cube, etc. in 1, we get a linear differential equation. We get linear differential equation with constant coefficients. with constant coefficients, and it can be solved it can be solved by known methods known methods discussed already. Okay, so let us write in short the steps for solving this kind of equations. Okay, what are the steps? So through these steps you can remember easily the method to solve. So whenever this kind of equation is given, we need to write put x is equal to e power z. Okay, so that z is equal to log x, and let d is written for d by dz. So then in the second step we write replace x into d by dx by d x square into d square by dx square by d square, and so on. Okay, so third step, by doing so Euler Cauchy equation reduces to linear differential equation with constant coefficients solved by known methods. Okay, so we are going to discuss one problem related to this.